Start again. Hello everyone, I'm Pawana and I'll be presenting on color psychology in space dynamics for the Space Habitat event 2025. This part of my systematic review research paper, but something as simple as color and lightning design could potentially contribute to the psychological well-being of astronauts and henceforth increase mission success rate. Let me start with the core challenge. Space exploration exposes astronauts to vulnerable environments for a long period of time, which can be a huge strike to their mental health. Current research shows that these psychological stressors don't just affect mood, personal dynamics, and ultimately mission success. We have heavily focused on life support systems and radiation protection, but we have largely ignored the psychological impact the habitat design can cause on astronauts. This is it's cost effective based color psychology to space, but more about creating mission specific environmental protocols that support astronaut resilience throughout the entire journey. You might be by focus on something as simple the most sophisticated spacecraft in history, but fails, and the stakes couldn't be higher. And here are first, long duration mission creates psychological stresses we have never dealt with before. A Mars mission isn't just longer than the current ISS stays, it's fundamentally different. Crew members face complete isolation from Earth, knowing that for over 2 years, no rescue is possible. Monotony and disrupted circadian. But that brings us to the second point. Traditional countermeasures simply can't scale to Mars length missions. Medications have side effects and limited supply. Communication delays make Earth based psychological support nearly impossible. VR systems require massive power and storage resources we cannot afford to waste. So, if the old methods won't work, what's the alternative? That's where our third point comes in. Color psychology offers something different, a scientifically validated low cost solution. Strategic use of cool and warm color schemes can actively support cognitive function, regulate circadian rhythms, and maintain healthy group dynamics without requiring complex technology or consumable resources. And finally, this isn't just about comfort or aesthetics. It's about empowering human resilience for future exploration. Every space mission is a massive investment, not just in money, but in people. Color psychology could be the small change shaping the future of human life beyond Earth. So now that we understand why color psychology matters, let's look at the real problems astronauts deal with. As space missions extend in duration and distance, astronauts face unique combination of psychological stresses. The most significant stresses are disrupted circadian rhythms, high workload, performance pressure, monotony of the environment, isolation, and confinement. Each of these factors, if unaddressed, can erode cognitive sharpness both well-being and the mission as a whole. Identify the key psychological stressors. This color psychology examines responses by blending insights from this field has proven effective in creating colors isn't simply about aesthetic. It's a tool we can use to positively shape mood, reduce stress, and stimulate optimal functioning. Color doesn't just affect how it's a measurable effect on both performance and social dynamics. The others, cool tones such as blues are linked to ideal for work zones. Warm tones like reds and oranges promote social bonding and enthusiasm, useful for communal and activity areas. Brighter, more saturated colors counteract the perception of claustrophobic or monotonous spaces, while tailored color choices now I'll brief zones depending on use and time of the day. Now that we've understood the concept, let's see what research says. To move from theory to evidence, I have systematically searched the literature to find out in space. So I searched for the Frontiers in Psychology, NASA Astrophysics Data System, research I used search terms like combining color psychology, space habitat, helping studies that tested color of lighting and exclude non-English studies as I don't have expertise in understanding them. For each study, I recorded study design, participant details, color intervention specifics. The standardized approach helped me compare studies where intervention type and setting because they were very different. I identified patterns across them rather than combining them statistically. The data was analyzed, some clear themes, human well-being and performance. Starting with psychological outcomes. This area focuses on how different colors and lighting conditions influence mood, stress, and overall emotional well-being. Across the different colors affect astronaut psychology, improved mood, and reduced anxiety. Cool colors, particularly blue and green, showed significant benefits for reducing visual fatigue and stress perception. A particularly compelling finding was that blue green white color combination reduced visual fatigue. What's important is that multicolor schemes, where lighting changes periodically rather than remaining static, actually helped counteract the psychological effects of monotony, which is a major challenge in confined environments. Across multiple studies, I saw consistent evidence that strategic color design reduces stress, Now, these psychological responses are closely linked to lighting conditions. So, let's look at what these types of light proved most effective. When I looked specifically at lighting conditions, one metric called correlated color temperature or CCT emerged as a particularly important. Light at 6300 Kelvin, which mimics natural daylight, consistently produced the best mood and satisfaction outcomes. In contrast, very warm lighting at 2700 Kelvin was associated with lower mood and reduced satisfaction. Yellow colored lighting specifically showed the highest level of what researchers call emotional habitability. In functional areas like workstation, blue green white combination enhanced performance and alertness. Interestingly, randomized stand changes in multicolor lighting rather than constant static colors actually help the astronauts in maintain better circadian rhythms. Interestingly, these effects don't occur in a vacuum. One fascinating finding I encountered was that color preferences actually change depending on body position, specifically in simulated microgravity. When participants were positioned as they would be in microgravity, they prefer lighter and cooler toned colors. But when simulated lunar gravity, participants showed stronger preference for warmer colors. This matters because it means a single color scheme might not be optimal across all mission phases and habitats. The good news is that the beneficial effects of strategic color design appear consistent across both high fidelity analog facilities and ISS research. I also found that color interventions become more effective in longer duration simulations. This suggests that psychological benefits increase over time. Even with this insights, several limitations remains, areas that future research still needs to address. Most studies lasted less than a week, but actual space missions last months or even years. Additionally, very little research has examined how color affects astronauts during night cycles. Finally, we need economic analysis, understanding not just that color design helps, but whether it's cost effective to implement in future lunar and Mars habitats. These gaps represent opportunities for future research. So, where do we go from here? Recognizing these gaps is only the beginning. The real progress starts when we act on them. Based on these results, I see four key areas where we can make this vision a reality. First, research. We need to encourage more studies specifically on color and lighting in space analogs and ISS projects. The evidence is promising, but we need more data from longer duration missions to really nail down the optimal protocols. Second, collaboration. This isn't just about psychology. We need to get psychologists working directly with spacecraft engineers and designers. The best color schemes in the world won't help if they can't be practically implemented in a space habitat. Third, implementation. We should be testing the color schemes in simulation environments right now and work on integrating adjustable lighting systems into the next generation of spacecraft. The technology already exists, we just need to make it mission standard. Finally, awareness. We need to teach the current and future astronaut crews about using light and color for their own well being. Simple things like understanding circadian schedules and personal color preference could make the mission significantly more manageable. Now, the next slide has the references I am using to conduct my research. Lastly, I would like to highlight that as we prepare for missions to Mars and beyond, we must remember that technology alone won't get us there. The human element, that is, keeping our explorers psychologically healthy and resilient, is just as crucial as any rocket or life support system. Color psychology offers us a simple but powerful way to support the people who will carry our species to the stars. This concludes my presentation on color psychology in space dynamics. Thank you for your attention.